Jai Hind to all. Myself Alok Kumar. Today in electronic devices we will see how to calculate the equilibrium concentration of electron and hole in conduction band and valence band. So this is the today's topic. So first of all, we will calculate the concentration of electrons in conduction band, right? So we will write concentration of electrons in conduction band, right? Or we can say this is N naught. We can say this is N naught, right? So how we can find the concentration? So this N naught will be is equal to EC to infinity NE into FE with respect to DE. So this will be the formula to calculate the electron concentration, right? Here in this formula, EC is the we can say EC is the lowest energy of the conduction band. If we consider this is the energy band diagram, and here we have this is your conduction band and this one is valence band. So here we can say this lowest energy level of conduction band is EC, and here we can say this one is EV, right? So EC is the lowest energy of the conduction band. Similarly, what is NE? NE is the energy density states, energy density states in conduction band. And what is FE? FE is the Fermi direct distribution function, or we can say direct distribution function, right? So first of all we will see the equation for this NE. How we can express this NE? NE can be written as 4 pi upon h cube into 2 mn star to the power 3 by 2 E minus EC to the power half. So this will be the formula for NE, or energy density states in conduction band. And what is this FE? This Fermi direct distribution function can be given as FE is equal to 1 upon 1 plus e to the power E minus EF upon KT. So this is the formula for Fermi direct distribution function, right? So if we multiply the available density states with the probability, then we can find the number of electrons in the conduction band, right? So now to solve it, we will write N naught is equal to integration EC to infinity. We will put the value of NE. It was 4 pi upon h cube into 2 mn star to the power 3 by 2 into E minus EC to the power half into 1 upon 1 plus e to the power E minus EF upon KT, right? And we are integrating it with respect to dE. In next step, we will write EC to infinity 4 pi upon h cube into 2 mn star to the power 3 by 2 E minus EC to the power half, right? And here we can write it as 1 upon e to the power E minus EF upon KT. Why? Because we have considered E is greater than EF, and in that case 1 will be very less than e to the power E minus EF upon KT. So we can neglect the 1, right? Now we can rearrange these terms and we can write it as EC to infinity 4 pi upon h cube into 2 mn star to the power 3 by 2 E minus EC to the power half and e to the power minus E minus EF upon KT with respect to dE we are doing, right? Now we can take the constant terms out from this integration. So n naught will be 4 pi upon h cube into 2 mn star to the power 3 by 2 and integration EC to infinity E minus EC to the power half and e to the power minus E minus EF upon KT with respect to dE. Now what we will do, we will add EC in this term and subtract EC from this term. So we can write 4 pi upon h cube into 2 mn star to the power 3 by 2 integration EC to infinity, right? So here we will write E minus EC to the power half, and here we can write e to the power minus E minus EF. We will add EC and subtract EC. So plus EC and minus EC divided by KT with respect to dE, right? Now we can modify this term. And we will break it into two parts. One part will contain E minus EC term, and second part will contain EC minus EF term. So we can break this exponential term into two parts, right? So how we will write it? So we can write n naught is equal to 4 pi upon h cube into 2 mn star to the power 3 by 2 integration EC to infinity E minus EC to the power 1 by 2 and e to the power so we should write e to the power minus E minus EC minus E minus EC, this and this, so E minus EC, so e to the power minus E minus EC divided by KT, right? And second term will be minus sign EC minus EF upon KT. So we can write the second term will be e to the power minus EC minus EF upon KT with respect to dE. Now here in this term we don't have value in terms of E, energy E, so we can take this out. So we will write n naught is equal to 4 pi upon h cube into 2 mn star to the power 3 by 2, right? We can take this out. So e to the power minus EC minus EF upon KT e to the power minus EC minus EF upon KT, right? Integration EC to infinity and E minus EC to the power half, E minus EC to the power half, and second term is E to the power minus E minus EC divided by KT, right, with respect to dE. So we will obtain this. Now we have a mathematical formula 0 to infinite integration 0 to infinite x to the power 1 by 2 and e to the power minus ax dx. It is equal to under root pi divided by 2 into a to the power 3 by 2, right? So we have this mathematical relation. So if we compare this with this, if we compare these two, then what I can write? I can write EC to infinity E minus EC to the power 1 by 2 e to the power minus E minus EC divided by KT with respect to dE, and it will be is equal to under root pi divided by 2 into 1 upon KT to the power 3 by 2, or it can be written as under root pi divided by 2 into KT to the power 3 by 2, right? So now final we can put this value in this equation, and we can have n naught is equal to 4 pi upon h cube, right, into 2 mn star to the power 3 by 2 and e to the power minus EC minus EF upon KT, right, this term, and into under root pi into KT to the power 3 by 2 divided by 2. So this will be the equation. So we can cancel out this. So now after rearranging the terms, we will get n naught is equal to 2 into 2 pi mn star into KT divided by h square to the power 3 by 2 into e to the power minus EC minus EF upon KT, right? And what is this? This is nothing but we can write it as NC. We can write it as NC. This is nothing but your NC. NC is what? NC is effective energy density states. Effective energy density states in conduction band, right? So the final value of n naught can be written as n naught, or the concentration of electrons in conduction band, or we can say equilibrium concentration of electrons So N naught, the final value can be written as N naught is equal to NC e to the power minus EC minus EF upon KT. So this will be the final value of concentration of electrons, right? In similar manner, we can find the concentration of holes, right? So to find the concentration of holes, we will see next is concentration of holes. Concentration of holes in valence band, or we can say equilibrium concentration of holes in valence band, or we can say thermal equilibrium concentration of holes, right? So to find the concentration of holes, we can write P naught is equal to integration minus infinity to EV, right, and NE and 1 minus FE with respect to DE, right. So this will be the formula to calculate the concentration of holes, right. Why we have taken this limit? Because again we can see the energy band diagram here. If I have a conduction band, so suppose this is conduction band and its lowest energy is EC, and here I have valence band, is its highest energy is EV. So we are taking the limit EV to minus infinity, right, or minus infinity to EV. So minus infinity to V, because in this region we want to find out the concentration of holes, right. So minus infinity to EV. So here NE represents, this NE is energy density states, in valence band, right. And again 1 minus FE we know FE is the Fermi Dirac distribution function, and FE represents the probability of electrons, right. So the probability of holes will be can be calculated with 1 minus FE, right. So this NE will be, the value of NE will be 4 pi upon h cube, right, 4 pi upon h cube into 2 MP star to the power 3 by 2, right, and EV minus E to the power 1 by 2. So this will be the value of NE in this case, right. And this 1 minus FE, this 1 minus FE can be calculated. It will be 1 minus 1 upon 1 plus E to the power E minus EF upon KT, right. So we can write it as 1 minus 1 plus E to the power E minus EF upon KT to the power minus 1, and if we expand this, I can write it as 1 minus E to the power E minus EF upon KT, right. After solving this, we will get E to the power E minus EF upon KT, or it can be written as E to the power minus EF minus E upon KT, right. So this will be the value of 1 minus FE. So we can use these values, and we can put these values in this equation, right. So the P naught will be integration minus infinite to EV, right, 4 pi upon h cube into 2 mp star to the power 3 by 2, right, and EV minus E to the power half, right, and then we can write e to the power minus EF minus E upon KT, right, e to the power minus EF minus E upon KT. With respect to dE, we are integrating it, right. Now this equation can be modified and it can be written as P naught is equal to, so we can take out the constant terms and we can write 4 pi upon h cube into 2 mp star to the power 3 by 2, right, integration minus infinity to EV minus E to the power half, EV minus E to the power half, and e to the power minus EF minus E upon KT with respect to dE we are solving, right. Now in this term I will add EV and subtract EV, right. So I will write P naught is equal to 4 pi upon h cube into 2 mp star to the power 3 by 2. Here mp star and mn star, they are these are the effective mass of electron and hole. Mp star represents the effective mass of holes, where in the calculation of n naught, that mn star was the effective mass of electrons, right. So 4 pi upon h cube 2 mp star to the power 3 by 2 and minus infinity to EV minus E to the power half, and here I can write minus EF minus E plus EV minus EV divided by KT with respect to dE, right. Again, after solving this, so 4 pi upon h cube into 2 mp star to the power 3 by 2. I will break this exponential term again, so I can write EV minus E to the power 1 by 2, and this exponential term I will break. So I will write it as e to the power, I will take EV minus E, so EV minus E, this term will be one side, so I can write minus EV minus E upon KT, and the second term will be e to the power minus EF minus EV minus EF minus EV upon KT with respect to dE, right. Now this term is it doesn't have any term of this energy E, so I can take it out. So P naught will be, P naught is equal to 4 pi upon h cube into 2 mp star to the power 3 by 2. So if I take it out, e to the power minus EF minus EV upon KT, right, and minus infinity to EV minus E to the power 1 by 2, right, and e to the power minus EV minus E divided by KT with respect to dE we are solving it, right. Again we can use the mathematical formula, and it is integration 0 to infinity x to the power 1 by 2 e to the power minus ax dx, it can be written as under root pi divided by 2 a to the power 3 by 2. And here in our case we have minus infinity to ev, integration minus infinity to ev minus e to the power half and e to the power minus ev minus e divided by kt with respect to dE. So it can be written as under root pi divided by 2 into 1 by kt to the power 3 by 2, or under root pi into kt to the power 3 by 2 divided by 2. So I can put this value, I can use this value into that equation. So the final equation will be P naught is equal to 4 pi upon h cube into 2 mp star to the power 3 by 2, right, into e to the power minus ef minus ev divided by kt into under root pi into kt to the power 3 by 2 divided by 2, right. So again we will cancel this 4 by 2, and after rearranging these terms I can write P naught is equal to 2 into 2 pi mp star, right, into kt divided by h cube to the power 3 by 2 into e to the power minus f minus ev divided by kt, or I can write this value as this is nothing but NV, right. And what is NV? NV is the effective energy density states in valence band. NV is the effective energy density states in valence band. So finally we can write P naught is equal to NV e to the power minus EF minus EV upon KT. So this is the final expression for the concentration of holes in valence band, right. So we have calculated two equations. One, we have calculated the concentration of electrons in conduction band, and equation was N naught is equal to NC e to the power minus EC minus EF upon KT. And next we have calculated P naught, that is concentration of holes in valence band, right. So P naught is equal to NV e to the power minus EF minus EV upon KT. So these are the two important derivations that we have done today, right. So these equations are important if we find the if we find out the concentration. Although using these equations we can find the position of the Fermi level in N type or P type semiconductor, right. So in this lecture we will stop here, right. Thank you.